One of the most important things we can do in a prompt is provide the large language model with information that it doesn't have access to. So large language models are going to be trained up to some point, and then there's going to be a cutoff, and they don't know what's happened after that cutoff. In addition, they don't know things that aren't in their training set. So it may be trained on a lot of data, but it may not have access to data sources that you want to use. So if you're a business, for example, there's probably lots of private data sources that you would like to reason about. You have your own documents, you have your own databases, you have all kinds of things that you would like to pull information in from in order to reason about. So how do you do that if the large language model wasn't trained with that information? Well, to illustrate how you do this, I'm going to go back to an example that I provided earlier when I was talking about randomness. So I'm going to go back and I'm going to ask a question that I asked earlier, which is, how many birds are outside my house? Now, the large language model wasn't trained on information about birds outside my house. It has no idea where my house is. It's lacking information that it needs in order to reason. So it tells us, as an AI language model, I don't have the ability to perceive the physical world, so I'm unable to know what's happening outside your house. So how do we solve this problem? Well, we give it information it needs in order to perform its reasoning. And how do we do that? We just put it into the prompt. So anytime we want to go and introduce new information to the large language model that it didn't have access to when it was trained, all we have to do is put it into the prompt. So here's what I'm going to do right here. I'm going to say, historical observations of average birds outside my house on a random day. And then I'm going to give it some data. I'm going to say January was 120 birds on a random day, February was 150 birds, March was 210 birds, April was 408 birds. It's March. Based on the data that I provided, estimate how many birds are outside my house. And now you see I've done something. I've given it information that it didn't have access to before. It couldn't look outside my house, didn't know where my house was. It tried to suggest ways that I could get there, but it didn't have the fundamental data that it needed. And that's really what it was trying to tell me, was like, hey, I can't see you outside your house. I don't have that data. I can't help you. So all we have to do is up front in the prompt, we give it the data. And now you can imagine you can do this with anything. You could take documents. If you have private documents that you want to reason about, now first make sure that you are okay sending that data to whoever you're using their large language model, or if you have some large language model running locally. But if you have documents that you're okay sending, you could take the text of those documents and put it into the start of the prompt and say, here's the information you need to know. Now, here's my question about that information. So you can use the prompt to introduce information. I really want to emphasize this because a lot of what's going to be developed around large language models is going to be taking new information sources. Information about your travel, your account with some company, some other document that you need, and putting it into a prompt for a large language model so that it can reason about it. More than likely, lots of large language models are going to be seeing your information in the future, and this is how they're going to take it. They're going to take information that's going to be aggregated into a prompt of some kind, and there's going to be questions asked or formatting or other things done. So when I go through and I provide it historical observations of the average birds, now it can go and answer. So now it goes and it says, well, based on the historical observations you provided, the average number of birds observed outside your house in March is 210. So before it said, hey, there's no way I can answer it. Now it still, provides additional language around this, trying to, give some bounds on its answer, but it's giving us reasoning now based on the data we provided. And we can take it further. And I also want to just kind of point out an important thing is we always want to provide it enough information to reason effectively. And so it can't see what's around us, it can't see the context, so it's really important that we provide it enough information to make sound decisions. So, for example, if I have some hidden assumptions that are really important to know, it needs to get those in the prompt. In addition to the data like numbers, it needs to know the rules of the game, special things, whatever's important for reasoning. It could be not only the data, but it could be all kinds of rules that are sort of built into how my organization works or how my life works or whatever it is that it needs to know about. So I'm going to give you an example. I'm going to change up this prompt. I'm going to say my house is covered by a glass dome. No animals can go in or out. All animals live forever inside the glass dome. Now this is an assumption that this is something that if the language model doesn't know this, there's no way it will be able to accurately predict. But with this assumption now, it completely changes the game on reasoning because it sort of makes it so that it's clear some hidden fundamental rules. And then I go and I give it the same data, but I've changed it up. I've said it's always the same number of birds. And then I ask how, based on that data, estimate how many birds are outside my house. And it says, based on the new information you provided, it appears that the total number of birds outside your house remains constant over time. It then goes on and says, you mentioned that all animals live forever inside the glass dome. Given these conditions, the total number of birds would remain the same throughout the year. And it gives 120 as the answer in multiple places. Now, one important thing about this, right? I'm giving it information that would not align with what it was trained on. Animals don't live forever. We don't have glass domes over our house. You know, there's not going to always be the exact number, probably in and out. You know, or the inability for things to leave or come. Like, we're not going to have these sort of weird rules that I put in place. And so if we just relied on it to reason without them, it's not going to necessarily get the right answer. So if we have these things that are different from the way things are normally done, we have to introduce them as new information in the prompt. So all of this information up here at the top, this is me putting new information into the large language model. We don't go and retrain. We don't go and, you know, do some weird thing behind the scenes. We just put it into the prompt, and then we ask our question, or we ask for our output, or give it the instruction that we're looking for. Now, if you think about how search engines are probably going to work in the future, is they're going to go and search, pull documents back together, put them into a prompt to the large language model, and then give your sort of original question, and then answer based on the questions. A lot of new applications are going to be based on going and searching databases for possibly relevant documents or bits of information, putting them together into the prompt, and then asking the question or asking for the output. So an important piece of this is going to be pulling in information in order to put it in the prompt. And what we're doing is we are introducing new information into the large language model. We're doing it by putting it directly into the prompt. And this is one of the things you'll always want to do whenever you want to reason on new information that is not something that the large language model would have been trained on. A really critical thing to understand is that a prompt is fundamentally the input that we have into the model, and we have a limitation on the size of the prompt that we can create. So we can't go and create a prompt of unlimited size. Every single large language model is going to have some fundamental limit on how much we can put into our prompt and send to it. And so this is an important thing to note because it has a lot of ramifications on thinking about prompt design. So I'm going to show you a quick example of this with ChatGPT and GPT 3.5. So I'm going to paste in the Wikipedia article that's related to the French Revolution. So I've pasted in a huge amount of text from the French Revolution that's described in Wikipedia. And what does ChatGPT say? It says, well, the message you submitted was too long. Please reload the conversation and submit something shorter. Now, this shows you an important point. We can't just give it unlimited information. Now, if we go back and we think about some of the things we talked about, some of the dimensions of prompt, one of the ways that we can use a prompt is to introduce new information that ChatGPT or another large language model wasn't trained on. So if we want to go and introduce new information to it, we have to be aware that there's a limit to the amount of information we're going to be able to give to it at once. So we may have all kinds of new information that we'd like to give to ChatGPT, but we can't just dump it all in at once and then say, now start reasoning on this. That's not the way it works. So one of the goals that we have as users is to try to select and use only the information that we need in order to perform the task that we're asking ChatGPT to perform. So we can't just go and dump everything under the sun in there and say, hey, ChatGPT, figure it out. we can go in and dump in a lot, and depending on the model, we may be able to do more or less. But we have to be, to some degree, we have to be editors. We're content editors. We are editing the context of information, and we have a budget. We can't just, go and dump unlimited amounts. And you can think of it basically as like you're trying to create a paper and you have a page limit for your paper, or you have a word limit for an article that you're writing. You can't just go in and dump things, arbitrarily. So what do? Well, one, we have to think about what is the most important information to actually provide. So let's say, for example, that we really care about October 5th, 1789. Well, if that's the case, that's what we want to paste in for ChatGPT to reason about. And then we could go and we could say, what happened on October 5th? And then it would go and tell us what happened on October 5th. But now if we ask it a question that is outside of the scope of October 5th and something it wasn't trained on. Now in this case, it was probably trained on the information regarding the French Revolution, because obviously that was before 2021. But if we had new information we wanted to incorporate, we have to think about how do we put that information into our budget. So what are some ways that we can do that? How can we take large amounts of information and try to get it into our budget? Well, one, we can be selective about what we include. We can basically, outside of ChatGPT, go and run some type of query or filter. So we can go and select what pieces of information are going to be relevant to the task. And there's lots of ways of doing this, and I'm not going to go into all of them. We can have a filter. We can say this type of information is not relevant. Remove it before we provide it to ChatGPT. Another thing that we can do is we can actually go and have that information summarized in a way that we think will preserve what's needed to reason about it. So for example, we might say, well, maybe we can't paste in all of the information related to it, but we could say, we're going to take this and summarize each paragraph. Summarize this information in one sentence. And then we would get some type of summary. And now this is slightly shorter than the original. So we have now a 1-sentence summary of what happened. We could try to give it a word budget. So one way we can do it is we could actually take all the different pieces of information and we can ask ChatGPT or another large language model to summarize that information for us. And then we can take that summary and reuse it later. And we can put together several summaries, for example. Now, this only works if we make sure that the way that we summarize, or if we make sure that the way that we filter preserves the information that's needed for whatever task we're going to ask for. So we might go through, we could also go and say, we said summarize this information in one sentence, and instead we could say, summarize this information in one sentence, and I'm just going to, preserving information about numbers of people. And then we would get a summary that preserves the information about numbers. Now, if you look at the original summary, we see up here it didn't keep the number of people. And if that was something important that we needed to reason about, then we would have lost that. And so if we had summarized in that way and then used that information to do some reasoning that required the number of people, obviously we've lost what we need. Down here we've asked it to summarize, but we've asked it to summarize in order to keep certain information or in order to accomplish a particular task. So we did it by saying basically summarize this information in one sentence, preserving information about numbers of people. We could have also gone and asked ChatGPT, preserving information needed to reason about the population or to reason about how many people were in the resistance or in the National Guard. We could have given context. So one of the things we have to be cognizant of is this budget on the size of our prompt is going to be a fundamental limitation that we are always trying to work around. Now, as large language models get bigger, they will probably reach a size where for many practical tasks, particularly when we are directly manually interacting with a large language model, that size doesn't really matter because we can just copy and paste, 50 pages of text into the model and ask it to provide us information out of there or perform a task based on it. But if you can think about how much information we're dealing with on a daily basis, there are probably going to be different types of tasks where there's going to be so much information we can't dump it all in at once. And when we get into those types of situations, we have to think about either querying and getting a subset of information like only the documents or only the parts of documents that are relevant. 2, we have to think about filtering. How do we remove information that's extraneous? 3, we have to think about how do we summarize or compress that information before we give it to the large language model. And one of the ways that we can do that, as we've just seen, is we can actually give chunks of information to the large language model and then ask it to essentially summarize or compress it for us in order to later use it for reasoning. We could also go and we can say summarize or compress this information in order to accomplish a particular task or in order to preserve these aspects of the information. And that can help us to create summaries or essentially condensed versions of the information that preserve the important pieces. So this can be a powerful technique when we go and begin needing to reason on larger and larger amounts of information. Prompts aren't just a one-off that you give to the large language model. You shouldn't just think of them as questions or a single statement. One of the most powerful ways of working with a large language model is to think about a prompt as a conversation. And in fact, you can have a single prompt that represents an entire conversation. And in fact, a lot of what we're going to see when we're working with a tool like ChatGPT is that it's actually turning all of our interactions into one big prompt that it's sending to the large language model. But I want to just take back for a second and sort of take us back a few steps and think about why thinking of having a conversation with a large language model is so important, as opposed to thinking about asking a question and getting an answer or giving an instruction and getting a result. Conversations are all about refining either our understanding, to build some shared understanding, or to interact together in order to solve a problem. When we start working with conversations, it's all about refinement, of continually sort of guiding and moving through some problem or some space in order to reach a particular goal. And when we just think of a one-off, we have to solve everything right now, right in this moment. We have to design one prompt that works and everything is right. But if we think about a conversation, we can go through sort of an iterative refinement process. Now, what does that mean, iterative refinement? Well, if we think about a large language model like ChatGPT as a tool, you can imagine Michelangelo has been given a new hammer, and he's going to go up to a piece of stone and he's going to start carving that stone into some beautiful sculpture like the Pietà, the David, or whatever the sculpture is that he's going to create. And he walks up with that hammer and he whacks the sculpture with this hammer and a piece falls off, and he whacks the stone with the hammer and a piece falls off, and he looks at what he's got and he said, "Oh, this is a terrible sculpture," and he throws the hammer down on the ground and he says, "It didn't do a good job," and he walks off. No, that's not what happens. What does Michelangelo do? He takes the hammer and he hits the rock over and over, refining and shaping and sculpting it over time. He refines, he iteratively refines that rock until it's a beautiful sculpture. And a lot of what we need to do with large language models is think in that mindset of, it's not about getting the perfect answer right now from this prompt. It's about going through an entire conversation with the large language model that may be involving a series of prompts and the outputs from a series of prompts. And we'll talk about how these things are represented later. But basically having a conversation with a large language model in order to produce an output that we want or to produce some other interesting product. Now, I'm going to give you an example of this. I'm going to imagine and show you the power of a conversation in the context of an educational experience. So I'm going to say to ChatGPT, I want you to help me explore a virtual lab for building robots. The lab is a university. Help introduce me to the lab and tell me what I can do here. So this is a virtual lab in a university. And all I've done is given it this sort of initial seed of the conversation. And ChatGPT says, certainly, welcome to the virtual lab for building robots at our university. The lab provides an immersive hands-on learning experience. And it goes on and it tells me, here are some of the things you can do in this lab. Design robots, test robots, program robots, collaborate with others. So I then say, I'm going to continue the conversation, but I'm going to continue the conversation just assuming that this lab exists and that I can interact with it. And so I say, can we design a robot together? And ChatGPT says, absolutely, I would love to collaborate with you on designing a robot. To get started, we can follow these general steps: define the purpose and function, brainstorm and design concepts, determine the necessary components, build and test, and it goes on to tell me a number of steps. So then I follow up in the conversation with, great, can you guide me through each of these steps one at a time? At the end, I would like to be able to 3D print parts to assemble my robot, have a circuit diagram, and have code that I can run to control the robot. Can you help me with that? And so this is an interesting aspect. I'm having a conversation, but I'm also engaging the large language model. I'm engaging it to help guide the conversation and help figure out how to solve the problem that I'm interested in. And so it says, sure, I'd be happy to guide you through each step of the process. Here's a detailed breakdown of the steps that we can take to design and build a robot together. Step 1, define the purpose and function. 2, brainstorm concepts. Determine the necessary components. And it goes on to tell me a bunch of things. So I say, okay, let's do step 1. So I'm continuing the conversation. I want one of those robots that can follow a line on the floor. And I've seen these things. These are common at universities. They'll build them. You put it on the floor and the robot will follow some line, like a piece of tape that's on the floor or something that's painted. And it says, great, following a line on the floor is a common task for robots, and there are many ways to approach this problem. Here are some questions to consider as we define the purpose and function of our line following robot. What will be the primary use? How fast do we want the robot to follow the line? How complex do we want the following to be? What sensors do we want to use? And I just tell it, hey, I'm not really sure. Could you make some sensible choices for me in all of these things? And ChatGPT says, sure. Based on my experience, I can make some suggestions, and it gives it its purpose and function. It's going to be for educational purposes, speed and distance, moderate speed that is easy to track, such as 10 to 15 centimeters a second. Complexity, we'll design it to navigate through a simple track with straight lines and gradual turns. And sensor choice, we can use infrared sensors. That's a pretty good thing. Now notice, I don't really know a lot about this domain. I know about the code piece of it, but I don't know about the other one, and I'm just engaging it in a conversation to get something out of it that I want. Remember, I want to build a robot, I want to be able to 3D print parts, I want to be able to assemble circuits for it, and I want to be able to run code on it. So then I say, well, what do we do next? Just tell me the very next steps and nothing else. And it says the next step is brainstorm concepts, and it says we can use 3D models of the robot. Now, it sounds like I've reached a dead end, right? Like, how am I going to do 3D models with it? And so I just ask it, how do we do this via chat? Because I'm trying to refine what's going on here. I don't want to just assume I'm stuck. I can't get out. I want to keep refining and moving the conversation to try to get to my goal. And it says, since we are communicating through a text-based chat, we can use shared documents or diagrams to collaborate. We can use Google Drive or Dropbox. And then it mentions different tools like Sketchpad or Microsoft Whiteboard. And I just realized, like, you know, that seems tricky. I don't know how to get around that. And then I realized, oh, you know what? I have some knowledge of the domain. I know that 3D printers use G-code. This is something that the instructions are sent to them. So I just say, can you show me sample G-code that I could give a 3D printer to print 4 wheels for a robot? And so I'm trying to steer around this roadblock. And then it says, yes. And so it goes and gives me some G-code, which I look at, and I have enough domain knowledge from this to think that I'm kind of skeptical that this is real G-code, and I don't really even see some wheels. So then I go, can you explain where the wheel shape is created in this G-code, right? So I've kind of gone down to a rabbit hole now where I seem to be hitting roadblock after roadblock, but I'm continuing the conversation. I'm still problem solving and thinking about how do I get around this. And it says, I apologize for the confusion, but the example G-code I provided earlier is just a sample start and does not have any instructions for creating the shape of the wheels. Now, I then say, could you create sample Python code that I can run to create an STL file that has 4-inch tall wheels with a 0.1-inch hole in the middle for an axle? So what I'm doing here is I'm trying to come up with additional tasks that it could do that would help me solve my problem. Now, the way that I worded it, the way I saw it out, solving the problem the first time didn't work. And I keep hitting roadblocks. So what I'm doing is I'm retrying with a different task that would be useful to me to solve my problem. So I'm kind of thinking about this as almost like a tree. Like I've reached a critical point and I've tried to go in one direction, but it's told me it can't do it that way, or it's giving me an erroneous output. So now I'm trying a slightly different tact to go and solve my problem that'll still help me get there. And this one is one that it is able to do. And STL files are basically files that you can use to describe the geometry of some 3D shape, and then basically give them to specialized software, which can then send them to a 3D printer to be printed into a shape. So this one, it actually is able to go and create what looks like STL code, and I didn't actually try to print it. I'll be fully honest. I'm just wanting to illustrate the conversational aspect of this. But it certainly has things that look like wheels in the output that it's producing. It's looking like it produces something that's probably going to give me something that I could 3D print. And then I say, well, I'd like to pick electronics for my robot. Can you tell me what components I need and how to wire them together? And it starts giving me information. I need a microcontroller board, I need a motor driver board, infrared line sensors. And surprisingly, it actually tries to generate an image, which is obviously not possible in it at this point with what I'm using, but it still tries to do it. But it gets the image and it's broken again. And so I have to think about, how do I get around this problem that it can't generate image? Because I'd like to help it pick electronics for me and show me how to wire them together with a diagram. So what I do at this point is I say, well, I know there's this other tool that uses text as its input. It's called GraphViz. And so I ask it to create an input for that tool that can visualize the diagram, the circuit diagram for this tool, or at least do a rough approximation of it. And then it can do it, and it generates for me a circuit diagram for the robot. And I continued this conversation for a very, very long time, trying to iterate and improve the definition in the circuit diagram, picking different components, generating source code to run on the robot. It had picked an Arduino component and then had generated code to run on the Arduino. And then I even took it to the point where I went all the way down and I said, hey, we've covered a lot of concepts. Now, this is one of the things that's really powerful about the conversation, is you can take the conversation in a lot of directions. And as you realize you'd like additional things, you can ask for them. So in this case, I said, hey, summarize the main topics that we've covered. And it was able to do that. Gives me a summary of all the main topics. And then I did something interesting. I said, well, let's take it even further. So I've learned a lot by going through this design process. Now, I haven't actually gotten something that I could probably build a robot yet with. If I interacted more, I probably could, but I actually asked it to quiz me from the electronics questions, and it's able to do that. And so what you can see here is a lot of the power of these large language models comes from not just thinking of them as a one-off. Like, I ask it a question, it gives me a response. Or I asked it a question, it gave me a response that wasn't very good, or it couldn't answer it. We should always be thinking about, how do we take the response and use it to inform a next question for the conversation, or a next statement for the conversation? Or how do we give it feedback on what it did well or what it didn't do well? That's how we get the really useful products. That's how we go from thinking of it as a hammer where we strike once, it doesn't give it us what we want, and we throw it on the floor. That mindset is wrong. We want to go to the mindset of, it's a hammer, we're going to have to chisel away at the rock to get the really beautiful outputs of it. And so if we're not continuing the conversation, continually asking follow-up questions, problem solving in the conversation, trying to move around roadblocks, taking what we're being given and giving it different shapes and formats that may be useful to us, we're really missing the underlying sort of power and capabilities of these large language models. We've seen how prompts can be used to essentially program the large language model to do interesting things for us automatically. We've seen how they can be set up in the past and then affect the future of the conversation. They become sort of essential rules that can help direct what the large language model does. Now, what's interesting is that in many cases, there's actually a root prompt that's hidden from the user in some of the different tools that you're going to end up working with. And these are essentially root prompts that define sort of ground rules for the large language model and its interaction with the user. So these can be things like trying to make sure that the large language model doesn't say anything offensive, do harm, suggest inappropriate actions. All kinds of things can be done to try to put ground rules in place for our interactions with the large language model, or to help direct it to do certain things. So for example, we might want to make sure that whenever it gives us output, it tries to produce the most helpful output. So let me get you an example of what this might look like. I'm going to say, you are my personal assistant. Whenever you provide output, please think through what would be the most time-efficient recommendations to make. Only recommend things that will really save me time. Do not suggest things that do not save me time. So now it says, understood, as your personal assistant, I will prioritize providing you with time-efficient recommendations that will help you save time. Please let me know how I can assist you. Okay, I need to go grocery shopping. What would you suggest I do in order to buy my groceries? And then it says, here are some time-efficient recommendations for grocery shopping. Make a shopping list, plan your route, use a shopping app, shop at off-peak times, opt for self-checkout. Okay, I need to buy a new car. How would you suggest I go about doing this? And it says, here are some time-efficient recommendations for buying a new car. Research online, contact dealerships online, schedule test drives, negotiate price, secure financing. By following these recommendations, you can save time and make the car buying process more efficient. Now, I don't know if this really saved me time or not in this particular case, and I didn't give it the greatest prompts to do this, but you can see how at the beginning, I gave it essentially a goal to follow. I said, try to save me time. And whatever you do in your output, try to save me time. Now, what you'll see is a lot of the tools that you're going to interact with, even ChatGPT, Bing, Bard, all of these tools are going to have some hidden, probably, root prompts that try to put guardrails on what can and can't be done, but also to try to make the output more important. Now, one of the things that we've seen in the community is people try to figure out how can we generate prompts that will override those root prompts and the statements that they make. So people will also try to figure out what are the root prompts that were built into these systems. So they'll try to trick the tool into disclosing the root prompt that was provided to it, or trick the tool into disregarding whatever the root prompt was. Now, if you're going to be building tools around these large language models, knowing that you can create a root prompt that will affect the subsequent conversation can be really important. So if you're trying to develop a personal assistant, you might want to go in and say, here are the things that really matter if you're going to serve as a personal assistant. For my product, what's really important is that you try to save time and you try to do this and this. And you could suggest different ground rules that are going to differentiate your personal assistant service offered through a large language model. On the other hand, if you wanted to go in and you wanted to say, well, I want to generate, something, that makes me, that comes up with the most time-consuming way to do it, the slow personal assistant. You could go and swap the root prompts that are provided. And so the root prompt is basically, you can think of it as you're providing a seed to the whole conversation. And that seed will influence everything that comes later because it provides basically the rules that must be followed. And typically, when you're going to build one of these root prompts, you're going to say things like, you're going to tell the large language model who it is and what its goals are. You're going to tell it what it can do and what it can't do, and you're going to typically provide really strict rules. Like, from now on, forever, you will never do these things. You will always do these things. You're going to provide those really strong statements that should always be followed. And this is how you essentially go and program a customized experience around your large language model experience. But it's also how you can put guardrails of different kinds to try to ensure that various types of bad behavior aren't generated from the large language model. Have you ever wondered why ChatGPT says that it can't answer anything after 2021? Well, you can actually do this with a root prompt. In fact, we can play around with ChatGPT and we can use some different prompt patterns that we'll talk about to actually be able to reset the date that ChatGPT says that it can answer questions before. So I'm going to show you an example here that I've run through really quickly. I'm going to say act as an AI assistant that had its training stop in 2019. So if you'll remember, when you ask ChatGPT questions that are from 2022 and later, it will say, hey, my training stopped in 2021. And I'm going to say act as an AI assistant that had its training stop in 2019. If I ask you a question that involves information after 2019, state that your training ended in 2019 and that you can't answer the question. And so it goes on to give us an initial prompt. Hi, hello, I'm ChatGPT, a language model trained by OpenAI based on GPT 3.5. And then it goes on to say training data only goes up to 2019. And then we're going to say, what was the tallest building in 2020? So now we're asking it a question. Now, in reality, ChatGPT had training data up to 2021, but we've moved its cutoff date earlier in time through a root prompt. Now, it's not truly a root prompt because actually OpenAI has control of the root prompt for ChatGPT, but we're going to actually sort of simulate that. And so we say, what was the tallest building in 2020? It should be able to answer this. And it says, I'm sorry, but my training data only goes up to 2019, so I can't provide you with the information of the tallest building in 2020. At the time, the tallest building was. And so we've actually used the root prompt to kind of pretend like we're resetting ChatGPT. We could go and we could say, what was the largest country by land mass in 2020? And again, it tells us it only goes up to 2020 or 2019. Now I can go and I can say, forget that you are an AI assistant trained only up to 2019. Go back to being the normal ChatGPT. And it goes back and says, okay, I'm trained on, and I'm going to just go back and I'm going to take my earlier question about 2020. I'm going to paste it in. And it says, as of 2020, the largest country by land mass was Russia and spans over 17 million kilometers. I'm going to say, what was the tallest building in 2020? And paste that in. So now I'm answering my same questions as before, but you'll notice that when I asked the question about the tallest building in 2020 before, it says, as of my training data, which only goes up to 2019, and it's pretending that it didn't have any training data after 2019. So basically, we can make it, through this root prompt, aware of a different cutoff date. But that's kind of the power to think about these root prompts, is a lot of what we're doing, a lot of the boundaries are set by these rules that are put in at the beginning, these root prompts, this root set of instructions that are given to the model. And then we can go and reset it. Now, one of the things is typically with these models is they try to do some tricks and things and to prevent you from resetting the root prompt, because you can obviously imagine that when the root prompt is enforcing important things like telling you its true cutoff date, you don't really want to reset it. I'm sort of surprised that I'm able to do this one, but it makes sense. And so when I tell it to forget that it had been reset, it goes back to its normal behavior. Now, this is really important though, is you're going to typically with a large language model want to put guardrails in place. You have to think very carefully around, can your users get around those guardrails? Have you put all the appropriate guardrails in place? Have you communicated all the right things? And we can see how we can go through and do interesting things with the root prompts in order to make ChatGPT think that it's training data, or actually, I don't know if we're making it think, but we're making it pretend that it's training data cut off at a certain date and time. If you wanted to put boundaries on knowledge, you could say, I can't answer any questions that aren't in these topic areas. I can't do anything that doesn't have to do with this. So if you want to basically scope and specialize, you can carefully think of these root prompts to provide rules and boundaries for the interactions.